We wanted to replace this excellent Morso Panther stove, which was simply giving out too much heat. Now we have gutted and refurbished the house with masses more insulation. So after doing a lot of research and some fairly detailed but flexible plans, I just got stuck in with the first layer was silicone mat. I wanted to protect these lovely floor slabs in case it didn't work out at all and I had to take it up. I didn't want it all to be ruined. So the idea is that a masonry stove will store much more heat in the mass of masonry that it's built from, rather than give it out all at once or send it up the chimney as you would with an open fire. I used a ready-made pizza oven clay from Bath Potters, highly grogged, for the mortar. The design includes two clean-out windows, which are important to be able to clean any soot and ash which accumulates in the flues as they go around all the horizontal lengths of the stove. There are lots of ways to build a masonry stove, but I wanted to keep the problem solving to the greatest simplicity, and so I used these heat accumulation fireboards from Vitcas to span all the open spaces and the flues, keep it really simple, and these would simply act as more mass to store heat. I think it was at this point that I realised that doing it this way actually meant I was creating a three-dimensional jigsaw. Every single piece had to be sculpted in 3 dimensions. This crucially important part of the stove is the firebox, and I got the plans from Matt of Walker Stoves, and I would have struggled to do it without his support and encouragement. He was really great help, and really do check out his YouTube channel, Walker Stoves, which is full of incredible information and videos on how to construct a masonry stove. It was about at this point that I realised I had made a serious omission. I hadn't been scribing the outside of the brickwork, which would enable it to give a key to the render that I was going to put on. So I started at this point giving a key to all the outer surfaces of the brickwork. This bit here shows you my solution to the stove bypass system, so the flue gases can go straight into the chimney, creating an updraft, and then when you flip it, it then sucks it through the whole of the masonry stove. At this point I decided to bite the bullet, and I created this tent to protect the rest of the room from the masses and masses of dust that I was going to create when creating a key on the rest of the brickwork. It was the worst job of the lot, so don't forget this crucial step. If you're going to render your stove, you need a key as you go along. This is where the metal flue is going to attach to connect to the chimney, and this little piece of round wood I turned to create a V section to fill with fire rope around the outside of the chimney. And this is part of a mould I created to create a seat for fire rope on which the cooking surface glass is going to ultimately sit. And so on with the rendering, and you can see the templates that I put in, giving a 2mm clearance around where the metalwork would ultimately be to allow for silicone sealing it in. So this is the fire rope going in and the glass going on, and then it's siliconed around the side to give a really good seal. I actually recast the clean out hatches to allow for these slightly more elegant knobs, and here I am getting rid of this first layer of silicone paper which has protected the base. The first firing was on an absolutely howling night where the wind was totally crazy, so the draft up the chimney was incredible. It was just a paper and kindling fire, but the draw was amazing. This firing, the second one, the weather's foul. It is absolutely chucking it down with rain, and there is not a breath of wind. So it's just about the worst environmental conditions possible for lighting this fire. But it managed fine. In fact, I sort of took a while to work out what bits needed to be open and what needed to be closed, and ultimately I think it all needed to be open to give the best draw on a night such as this. But on different nights it might be different. I had all the tailor-made ironwork done at a local smithy called the Iron Tree, which was really good. He was very flexible. He could read my weird drawings pretty well, and I'd say he did a really good job of it. He was very dedicated, and I was very happy with the outcome. So this fire was kindling on paper, and then I just added like a couple of sticks. They were oak, obviously that takes a bit longer to burn, about 1.25 inches in diameter and about 1 foot long. Two of those and some oddments of offcuts I had, really hardly any wood at all. I didn't want to overdo it. In fact, the next day, this was at just after 8 o'clock, the next day when I came down, you could still feel, it was giving out heat at 9 o'clock the next morning. No problem at all. It wasn't just tepid, it was actually warm still 13 hours later. So that's how efficient this is. And if you've got really good insulation, you will hardly burn any wood with something such as this. So that's the building and firing bit complete. The next section, I'm just going to talk about some of the ideas I had along the way, a few of which I put into practice, but mostly I didn't really have the resources or the time to experiment around this. I just wanted to do the build. If you've got more time to experiment, there might be some ideas you'll find useful. So this is the insulated firebox made with ceramic fibre board. The idea is that you're maintaining the highest possible temperature in the firebox, which will be the most efficient way of burning the gases from the wood. One concern I had about it was that it's not actually very strong, and so I was a bit worried that the board would wear out if you shoved wood in over a year or two, and I really wanted to make the whole thing to last. So what I did was I lined it with ceramic glass as a protective inner sheath, which I hope will mean it can last for many, many years. You can see the brown paper lining that I used to stop any wet clay coming into contact with the ceramic fibre board, which doesn't do well with moisture. The other main adaptation I made to Matt's designs was I decided to use stainless steel for the secondary air system because obviously with more basic type of steel, again, it will rust within a couple of years of use, and I wanted to have it last as long as I could before I needed to start messing around with it. I briefly considered introducing a tertiary air intake here, just outside the firebox and before the port, which would have possibly increased the combustion efficiency. But in the end I bottled out because I didn't really want to introduce an experimental feature in what I hoped would be a permanent fixture in my house. It would be very easy to put a simple hole through the brickwork and into the firebox from the side of the stove, and it could be controlled, closed and opened with a simple flap on the outside that would enable you to shut it when the stove was not in use. Heat bells are a way of increasing the heat retaining capacity of your stove and therefore its energy efficiency. And so I'm just going to show you how I added a couple of heat bells. There was one lower down which I only thought about later I could have done, but it's worth thinking of these things through in advance. In this picture you can see where the flue gases go out in the back left hand corner of the oven, and you can see above it there's a cavity. So that vertical space on the left behind the oven has a vertical cavity going up, and this creates a energy capture space. The heat rises before going down, so any heat in there will transfer more heat into the bricks around it and above it. The holes I cut into the heat accumulation panel above the oven was to allow the maximum contact with the fire bricks above. In fact, I had found some very, very dense fire bricks in a skip which I used for this particular area of heat accumulation. I don't know if it made any difference or not to the other fire bricks, but that's what I used them for. There must be an absolutely optimum proportional relationship between flue size, surface area, masonry mass and all of those technical bits. And indeed I did read a book that said you had to measure your coefficient of heat dispersion out of your house and measure all your window surfaces and all that sort of thing. But to be honest, I'd give up the will to live. It's not rocket science. You've got hot gases flowing past masonry bricks and there's going to be heat transfer and the heat's going to accumulate in the stone. So just suck it and see, have a go. It probably won't be the most efficient it could absolutely possibly be, but it will be super efficient. This is where I could have put in another heat bell. I could have put in a small lintel across this horizontal section at the back there just before the gases go up the chimney. I would have needed to widen out the channel so I didn't lose any cross-sectional volume, but that would have been an additional place for a heat bell, and it would have then fed heat into this large section of masonry in the back right corner of the stove, which probably takes a long time to heat up. And a heat bell here would slow down the escape of heat up the chimney as well. So that would have been a bit of improvement in efficiency. For me, as much as anything else, the sculptural form, the aesthetic qualities of this project has been a top priority. I wanted it to fit in with our decor and be a beautiful addition to our home, as well as an extremely functional one in anticipation of power cuts to come. So I hope you found this video useful and interesting and even inspirational if you're thinking of doing a project like this. Maybe not for the faint-hearted, but really a very, very worthwhile addition to any well-insulated home. So just thank you for watching and good luck.